Hello. Now we are going to look at the quadratic formula. So the quadratic formula, also called the minus b formula, is a formula that gives us the roots of quadratic equations. So we already know that to find the roots of quadratic equations, we should try to factorize. So we start out with a quadratic like this, and we try to break it up into two brackets multiplied together, and then we set each bracket equal to 0 independently. That's what we should always try first. But sometimes we won't be able to find factors that work. And in that case, we need this minus b formula, the quadratic formula. And this formula is on page 20 in our log tables. But we're going to need it quite regularly, so we probably need to memorize it. But it is on page 20 in our log tables if we forget, or formula tables. Now, we know that a quadratic, when we have it all tidied up, is written in the form where we have x squared first, and then x, and then a constant term, so just a number, is equal to 0. That's how we have things written when we're looking for the roots of a quadratic. And when we want to use this formula, we have to be careful that this is the order that we have everything written in. This is the form we have our quadratic in. So if we look at the rule, the formula that we are going to be practicing today, we have x is equal to minus b plus or minus the square root of b squared minus 4ac, and everything is divided by 2 times a. So what's a, b, and c? A is the coefficient of the x squared term. It's the number in front of the x squared term. B is the coefficient of the x term. It's here and here. And c is the constant, the term that doesn't involve x. And it goes here. Now this is a fairly complex looking formula, but it will always work exactly the same way, which is a nice thing about it. So over time, we'll get more and more comfortable with it, and it'll be a really easy question when we see something where we need to use the minus b formula or the quadratic formula. But we want to make sure that we start out using our structure carefully. So the order, as we say here, matters. We have to have x squared and then x, and then the constant equals 0, and that's the only time we can use the quadratic formula. But if we've got it like that, then we can just sub into our formula. So we always try to factorize first, but there's a caveat. If in the exam they ask us for our answer in surd form, a surd is a square root, or any kind of root. So the square root that you can see in the formula here is a surd, or rather, when you have a number underneath a square root, it's a surd. So if they ask for our answer, our roots of our equation in surd form, or to a particular number of decimal places, we're almost guaranteed to need this formula. So we should have a quick look to see if we can factorize, but basically always we're going to need to use the minus b formula or the quadratic formula if they ask for our answer in surd form or in decimal form. So anytime we see this now, if we're asked for our answer in surd form or decimal form, we need to think to ourselves, we're going to need to use this minus b formula on page 20 in our log tables. Now let's put this formula into practice. As we do this, I just want to remind you that we are still talking about the roots of a quadratic. So a smiley face looking function, this is a positive quadratic because there's a positive in front of the x squared. So it's a smiley face looking function. This is the graph of the quadratic that we've got here. And we are looking, when we find this equals 0, we're finding where y is equal to 0. So where do we cross the x axis? So where does our smiley face cross the x axis? So these 2 points here is what we're looking for. So can we find them using our minus b formula? Well, we should try to factorize first. So we take our first term and our last term and multiply them together. So we have 2 by minus 3 is equal to minus 6. So then we would look for all the stuff that multiplies together to give that. So we'd have minus 1 by 6, or we would have minus 2 by 3, or vice versa. None of them are going to get us to 4. So we give up on that, say, can't factorize, our method doesn't work for that, so let's see if we can use the minus b formula. So we already have our quadratic in the form of ax squared plus bx plus c. So let's write down our formula. Always write down your formula first. And we have x is going to be equal to minus b plus or minus the square root of b squared minus 4ac, all divided, everything divided by 2a. So everything here is divided by 2 times a. Let's define what a, b, and c is. Well, we have ax squared plus bx plus c, so a is 2, b is 4, and we have to be careful here, c is minus 3. It is not plus 3. So we need to be careful. The signs in front of our letters matter. So c is minus 3. Now we've got that, we just sub that in to our equation, and we put everything in brackets. So b is 4 plus or minus square root of 4 squared minus 4 times a is 2, c is minus 3, and then all of this is divided by 2 times a, which is 2 times a is 2. So we tidy this down. We put the bit underneath the we put the bit underneath the square root, underneath the surd, into our calculators, and we will get 40. So we get 16 and 24, and we get 40 underneath our square root. So when we tidy that up, we're going to have minus 4 plus or minus the square root of 40, all divided by 4. 2 by 2 is 4. And this plus or minus means we're going to get 2 different answers. We know that we should get 2 roots most of the time for our quadratics. So this plus or minus is going to give us our 2 different roots. Now, just to point out, you can simplify this. 40 can be written as, right, our next line. 40 could be written as 4 multiplied by 10 over 4, and the square root of 4 is 2. So to simplify that down, plus or minus 2 root 10 all over 4. It's a common factor of 4 top and bottom, so we could divide that out and we'd end up with minus 2 plus or minus the square root of 10 all over 2. It's good practice to try and do that type of simplification as we're going. In an exam, it would be perfectly fine to go with it in this form. We wouldn't lose any marks for that, but when we're practicing, it's good to try and simplify where we can. Now, at this point, we have our plus or minus business, and what we're going to do is say, well, I'm not interested in just plus or minus. I want to actually have a number answer. So x could be equal to minus 2 plus root 10, all divided by 2, or x could be equal to minus 2 plus or minus the square root, could be equal to minus root 10 all over 2. Now, this is our answer in surd form. So this line here is where we would stop if we were asked for our answer in surd form. This is surd form. That is our answer in surd form. If we were asked for that, then we would stop at that point and we'd say we've got our answer. But sometimes we will be asked to give it to, say, 2 decimal places, in which case we put this into our calculator exactly as it's written, and we will get our answer. And to go to 2 decimal places, we would get minus 0.58, and x is equal to, or sorry, approximately equal to, because this isn't giving all of the decimal places, minus 2.58. And this would be our answer to 2 decimal places. So 2 decimal places. And if we're asked for our answer in a particular form, we have to give it in that form to get full marks. And again, what we have just found, this is one of the roots of our quadratic, where it crosses the x-axis, and this is the other root of our quadratic, where this crosses the x-axis. When we graph it, we're at 0.58, so about 0.6, and at minus 2.58, about minus 2.6. And that's where we're crossing our x-axis. So visually, that's what we're doing. Now, if we get one like this, that's in a little bit of a mess, I remember back to the fact I've still got a quadratic, so I'm going to try and factorize it and try and simplify things. So if I order this around so that it's in the right form, ax squared plus bx plus c, I need to minus 10x from both sides. And I want to write the x squared term and then the x term and then the constant term. Have everything in order so that I know exactly what I'm talking about. Now this is in the nice form where I know what I'm doing with each step. I could try and factorize this, and in point of fact, this will actually factorize. This will factorize. If you go down through your steps, you will be able to get this out to the bracket. 3x plus 2 on x minus 4 is equal to 0, and you'd be able to get your roots. I will leave it to you to do that. That isn't the focus of our work today. But this does actually factorize, and I'm doing this example just to highlight again, this actually works for any quadratic that we pick. So let's use our minus b formula and see if we actually get our same root. So we'd end up with x is equal to minus 2 over 3 and x is equal to 4 for our roots. So now we have it in the form ax squared plus bx plus c. I'll write down my minus b formula. Now I'd have it in the right order. A is equal to 3. B is equal to minus 10. So we'd be careful of our signs. It's equal to minus 10. And C is equal to minus 8. And now I'm going to sub in. And as I sub in, I put absolutely everything I'm substituting in my A, my B, and my C inside of brackets, so I don't make any mistake. And then I'm going to simplify what's underneath my square root. I put all of this into my calculator. When I've done that, I can now get the square root of 196, and in this case, it actually works out to a nice number. I don't end up with awkward decimals this time like root 10, or surds I should say. I end up with 14. Square root of 196 is 14. So now I can break up my x into my two different possibilities. Again, our plus or minus here means that x could be 10 plus 14 all over 6, or x could be 10 minus 14 over 6. If we get that, we get x is equal to 24 all over 6 is equal to 4, or x is equal to minus 4 all over 6, which is minus 2 all over 3. And if we are okay with our rearranging, we would be able to see that we get the same thing as we did from our factorizing method. So again, this has given me the roots of my quadratic. X is 4 is where I cross the x-axis, and x is minus 2/3 is where I cross the x-axis, where y is equal to 0. So when it's in this version, I have y is equal to this quadratic, and I'm looking for where my y is equal to 0, where I'm crossing my x-axis. Always reinforce for yourself that that's what you're doing, because in the long run, we need to be able to make this strong link between this visual element of the function as a graph and the function's behavior in algebra. And that is what we need for using our quadratic formula, or the minus b formula. And it's on page 20